Hello everyone, welcome to SPEC eLearn, the online learning channel dedicated to chemical engineers. Interview questions, distillation part 5. I would appreciate if you subscribe to the channel, which is striving hard to deliver valuable knowledge content for your career progress. So subscribe now before you forget. For every question, you are given 20 seconds to think about your answer. Then the answer will appear. Check your answer is correct. Distillation part 5 consists of 5 questions. Question number 26. What do you mean by quality of feed? What are the different qualities of feed usually considered in designing distillation column in the industries? If the feed to the distillation column is 20 mole % vapor, what is the value of Q? Your time starts now. Your time is up. The answer. The quality of feed means the fraction of feed that is liquid. The quality of feed is denoted by the term Q. When the feed is saturated liquid, Q is equal to 1. And when the feed is saturated vapor, Q is 0. Your distillation column can be designed to take feed that may fall under the following categories. 1. Subcool liquid. 2. Bubble point liquid. 3. Partially vaporized feed. 4. Dew point vapor. And 5. Superheated vapor. This table presents the values of Q for the above mentioned different types of feed. For subcool liquid feed, the value of Q is greater than 1. For feed liquid at its bubble point, Q is equal to 1. For partially vaporized feed, the value of Q lies between 1 and 0. For a feed vapor at dew point, Q is equal to 0. For superheated vapor feed, Q is less than 1. Out of these 5 types of feed described above, superheated vapor is not normally encountered in the industrial applications. So we consider only 4 categories of feed under 1 to 4 for distillation column design and analysis. Now coming to the third part of the question, the vapor percentage of the feed is 20 mole %. Hence, the value of Q equals 1 minus 0.2, which equals 0.8, 80% liquid. Question number 27. It consists of 2 parts. Part A. What is the significance of wear height on a tray in a distillation column. B. You have two tray columns, one operating at above atmospheric pressure and another operating under vacuum. Which one of these two columns will have lower wear height? Give a reason for your answer. Your time starts now. Your time is up. The answer. The wear height is the plate parameter that has the most significant effect on the plate efficiency. As the wear height is increased, the plate efficiency increases. But the improvement in efficiency is achieved at the expense of higher pressure drop and entrainment. This figure illustrates the outlet wear on a tray in a tray column. The liquid froth flows across the tray and overflows the wear into the downcomer. The liquid froth height on the tray and the pressure drop across the tray is a function of the wear height, and so is the tray efficiency. What is shown in this picture is a sieve tray with the outlet wear. The tray column working under vacuum will have lower wear height as compared to column operating above atmospheric pressure. The wear height in columns operating in atmospheric pressure and above is usually in the range of 40 to 100 mm, with 50 mm being the most common. In vacuum distillation column, due to reasons for keeping the tray pressure drop low, the wear height may be as low as 6 to 10 mm. This is precisely the reason why vacuum distillation columns have lower efficiency. Question number 28. What is turn down? What is the single most important factor that limits the turn down? Your time starts now. Your time is up. The answer. Turn down is the minimum flow rate at which the column begins to lose mass transfer efficiency significantly. All types of trays have reasonably good turn down, 2:1. In most cases, the turn down is limited with the loss of efficiency, which has different causes for different devices. In all cases, the basic problem is inadequate liquid vapor contact. In sieve trays, the excessive weeping liquid falls through the column without flowing across the trays. In valve trays, at low flow rates, the valve remains closed at a large part of the tray. significant quantity of liquid flows across the tray without contacting the vapor stream. In the case of packing at low flow rates, liquid distributors can no longer achieve uniform distribution because the liquid level in the distributor is too low that the liquid issuing from the holes get swayed by the gas. In general, packing have better turn down than trays, generally 10:1 for wetting liquids. Valve trays have better turn down than sieve trays, generally at least 3:1. Question number 29. How is the operating pressure is controlled in a distillation column? Explain with a sketch. Your time starts now. The time is up. The answer. In distillation column, the pressure is maintained by the condenser. It is the condensation of the overhead vapors that causes the pressure to decrease. The amount of vapor generated in the column depends on the quantity of feed and the boil-up ratio. For the column pressure to maintain constant, the amount of vapor generated should equal the vapor condensed. Otherwise, pressure will vary. This is done by manipulating the flow rate of cooling medium to the condenser. For example, if it's a water-cooled condenser, then the water flow rate has to be adjusted through a pressure control valve. To understand it better, take a look at the picture of working of a distillation column. The steam fed to the reboiler generates vapor. The vapor moves up the column and comes into contact with the liquid on the trays, and the mass transfer takes place. The light product, upon enrichment, leaves the column as overhead vapor and condenses by exchanging heat with the cooling water in the condenser. So it is a condensation that removes the vapor produced by the reboiler. Now assume that the overhead vapor quantity is capital M and the amount condensed in the condenser is small m. Now the pressure will maintain if capital M equals small m. Otherwise, the pressure will increase or decrease depending on whether capital M is greater than m or capital M is smaller than m. This figure illustrates a typical pressure control system in a distillation column. Note the cooling water flow rate to the condenser is used to regulate the amount of condensation and thereby to maintain the pressure in the column. Question number 30, Part A. What is an azeotrope? How many types of azeotropes are there? How do you separate an azeotrope? Your time starts now. Your time is up. The answer. Azeotropes are binary mixers having the same composition in liquid and vapor phase and boil at constant temperature. Azeotropic mixtures are formed by non-ideal solutions. They may have boiling points either greater than both the components or less than both the components. Some liquids on mixing form azeotropes. In such cases, it is not possible to separate the components by fractional distillation. Azeotropes are of two types. 1. Minimum boiling azeotrope. 2. Maximum boiling azeotropes. Minimum boiling azeotrope. The solutions that show large positive deviation from Raoult's law form minimum boiling azeotrope at specific composition. The boiling point of the azeotrope is lower than the boiling points of its constituents. Examples of minimum boiling azeotropes are ethanol water. The concentration of 95% ethanol is called azeotrope composition. Maximum boiling azeotrope. The solutions that show large negative deviation from Raoult's law form maximum boiling azeotrope at specific composition. The boiling point of the azeotrope is higher than the boiling points of its constituents. Examples of maximum boiling azeotrope is nitric acid and water. The concentration of 68% nitric acid and 32% water by mass is called azeotrope composition with boiling point of 393.5 degree Kelvin. This figure shows the temperature composition diagram of minimum boiling and maximum boiling azeotropes. The figure on the left is the maximum boiling azeotrope. Note that both the pure components have a lower boiling point than the azeotropic mixture. The figure on the right is an example of a minimum boiling azeotrope. In this case, the azeotropic mixture has a boiling point lower than that of its constituents. How do you separate an azeotrope? One of the methods is by azeotropic distillation. Azeotropic distillation is one in which a solvent is added that will increase the volatility between the light and the heavy component. The interaction of the solvent called reagent with one of the components changes the volatility of the solvent and the component to which it is attached. The azeotropic solvent should have volatility near the major component desired in the overhead product. A good example of azeotropic distillation is water and ethanol mixer separation. Water and ethanol forms azeotrope at some point in the distillation process at 95% concentration, which is a barrier to separation by conventional fractional distillation to produce 99.95% anhydrous ethanol. Cyclohexane is one of the solvents used for production of anhydrous ethanol. It is used as an entrainer. The ternary mixture forms a ternary azeotrope with a different ethanol concentration, which allows ethanol to concentrate in the bottom stream. This azeotropic mixture, leaving the overhead, is separated to recover the entrainer and the ethanol. Question number 30, part B. Shown below is the equilibrium diagram of a minimum boiling azeotrope. Identify the azeotropic composition in the graph, the region where the equilibrium value K is less than 1 and the region where the value of K is greater than 1. Your time starts now. Your time is up. The answer. The point M, where the diagonal line and the equilibrium line intersect each other, is the azeotropic composition of the liquid mixture. The part of the curve on the left of the point M is a region where K is less than 1. That is, the component B is richer in the vapor phase. The part of the curve on the right of the point M is a region where K is greater than 1. That means the vapor is richer in component A. Please subscribe to our channel and get updates on the upcoming courses by pressing the subscribe button. It will motivate us to produce free, knowledge-rich video content for you. With this, we have come to the end of the presentation. Please give your comments, if any, about this course after you finished viewing this video. Share with your friends and colleagues to reach out to large number of career-oriented professional students. Thank you for watching.